Okay, so let's say we want to solve this. Now, we haven't done any factoring examples where the x squared has a constant multiple, or has a constant that's not equal to 1. And we can try doing that, or we can look at these formulas, which are conveniently at the top of this page, and see if I can get something that fits the form of one of these expressions. So, do I have a square plus a square? Well, 1 is a square because 1 is 1 times 1. And 25x squared is a squared because that's 5x times 5x. So, if A is 5x and B is 1, what do I get? I have 5x squared minus 2 times 5x, that would be minus 10x, so that fits perfectly, plus 1 squared. So this fits the second form. So what this is it's an expression of the form a minus b squared, and of course we still have a 0 on the right. Well, my a is 5x, my b is 1, and that's what we get. Now what does this mean? Well, you don't have to write out this step, but just in case you forget what it means to square something, that's what it means. You take it times itself. And when you have a product equal to 0, either the first part's 0, which here it would mean this, or the second part's 0, which means the same thing. And then it's easy for me to see that x would have to be 1/5. Now, if you don't believe me, we could always check our work. 25 times 1/5 squared, well, 1/5 squared is 1/25, minus 10 times 1/5, I could write that as 10 over 5, plus 1 equals 0. So look what I have here. I have 25 over 25, which is going to be 1, minus 10 over 5, which is going to be 2, and this works. Now, could I factor using a different method? Did I need to know this formula? There are other methods. As a matter of fact, maybe we should start practicing trying to factor quadratic polynomials where the coefficient of x squared is not equal to 1. And let's look at some examples next. However, if you do have something that falls into one of these forms, you can get around that without having to use any other techniques at all. Just recognize it's of the formula and then plug in. And as you see, we're done.